As director of RWE Pembroke Net Zero Centre, Richard represents, originates and coordinates RWE group activities in South Wales, including Celtic Sea, Floating Wind and downstream RWE decarbonisation projects, green hydrogen, CCS, hydrogen combustion power batteries, and shared supply to the future.
Thank you very much. Yeah, it's one thing about being in the power industry, you end up being a jack of all trades and a master of none. So I've been blown away by some of the technical detail in the presentations I've seen over the last couple of days. What I'm going to try and give you is a bit more of a sort of practical view of what we're trying to do on the ground. As we're moving out of years of talking about what we do stuff. So RWE, huge investor in the UK, big investor in Wales, one of the biggest investors into Wales. We spent about $1 billion over the last 10 years in Wales. Pembroke itself, which is where our station manager there for the last 4 or 5 years prior to this role, is one of the largest and most efficient CCGTs in Europe. Has the advantage of seawater cooling, which gives you a you've got 5 large modules down there that are all identical. So it was designed to base load. Actually, in reality, from the first day it was built, it's what we call 250. It's come on off every day. That's recently it was driven around what wind predominant. Oh, the wind's blowing hard. Even this, the most efficient power station in the UK, gets put off at times, which is impressive, and it's showing where we're going in the future. So increasingly, we're expecting this power station to run less and less and more around peaks and periods of load. Nevertheless, being one of the most efficient, it's also one of the first choices to run in the UK. So it does run a lot. We were forecasting 4 million tonnes of CO2 a year. So the computing done what it's done, and the fact that we were supporting it. It's been like 5 million tonnes a year this year, 5.4 million tonnes. It's a huge opportunity to decarbonise, but it's also uncomfortable. It's one of the biggest point sources of Wales. We started about 4 years ago looking at what we could do. What are your options to decarbonise this by 2025? It's absolutely essential to supply in the UK. What can you do to decarbonise on this scale? We quickly became aware of it where you're situated. You're situated on the middle of the paper on the big central ports in the UK, surrounded by ports. So there has to be something you can do, and we looked at all the implemented options. What we developed was the Pembroke Net Zero Centre concept. I zoomed in a bit there, trying to let you see it. It's become quite complicated, actually. This was quite a simple introduction we got started. We originally had the power station in the middle. What can you do to influence the power station? To become a power station. But actually, on that kind of scale, 500 tonnes a year, it's going to take a while before you get there. So RWE is focused in the short to medium term around building out renewable power, big ambitions, but see huge opportunity out there with a target at least a gigawatt, not 2, but and that power apprenticeship. Big ambitions around green hydrogen electrolysis, producing green hydrogen at scale. Once there's sufficient excess, effectively you need renewable power to make that sensible to do. On the transmission of that into a local industry, homes potentially, and ultimately once you've got enough power station. So we've got hydrogen in the middle of this in the end, push the power station to the side, and we see the power station really as an enabler for that kind of future transition. It's a demand for hydrogen, it's a swallower of hydrogen, enable investment. I'll talk more about that. You then, having realised it can take us 15, 20 years to build out access to hydrogen, surface power. But we'll start now but we needed a volume. So although we're not intending to produce blue hydrogen, we are supporting and lobbying for the acceptance of blue hydrogen as part of the enabler of this whole energy. So Welsh Government are nervous around blue hydrogen in terms of locking in fossil fuel. They often tell us that. Personally, I don't see the difference between that and carbon capture in terms of locking in fossil fuel. You are locking in short to medium term capability that helps you get a head start on stuff. So we are working with Shell across Europe actually, but this is our lead today. The least part of the power station land for blue hydrogen production. They're going to do that at scale. It's early access to hydrogen volume for power station testing. Gives us CO2 disposal infrastructure that will provide traction, pipework, shipping to get the CO2 away. That then enables us to follow that up with post-combustion power station. So we're trying to do a whole integrated energy transition. We almost look at this like as an example of the entire UK energy transition within 300 hectares site. On here as well, you'll see synchronous condenser. That's a big spinning inertia product which supports multi-control down whale grid. Helps stabilize wind. It doesn't provide the inertia that the old power stations used to provide, but we see that as helping to run the power station a bit less, particularly overnight, before, and a large battery product to help time shift power. But we're working on all aspects of this. We kind of drew that thinking that will be complicated. We've even got shared heat on there, waste heat to local industry. We're actually still on with all these projects. We might do more. It's a complex piece of work. A bit more. So where we are, what we're doing. Green hydrogen production in the end from renewable power. We are at the moment we're constrained within the local area. We haven't got a hydrogen distribution system, so we're using green hydrogen production. 2 projects live at the moment, and they're targeting direct supply of local industry with green hydrogen to displace methane from their process. Talked about releasing power station land for blue hydrogen production, supporting development of CO2 infrastructure, jetties, ships, to develop CO2 export capability from the haven, and have access to a national pipeline system. Local disposal, we're going to need shipping, all of South Wales needs shipping. But we're trying to lead that whole process and establish CO2 shipping from the haven. 250 megawatts of batteries, that's a big battery project. Few hour bird time roughly on that, so it's not long-term storage, but it's real peak for all of these things help run the power station with less. This is a good project. And shared heat. Potentially the project is to use waste heat from the power station, low-grade heat from the power station, across to the LNG terminals to evaporate their LNG. Be a huge swing. About 2% of the gas they import is just to boil that back into gas. So that's a massive CO2 saving. So where are we? The power station itself, we've just completed 40% study on our 40% blend of hydrogen combustion. That's the GE, the OEM of the machines themselves. They've actually suggested you can probably go past 40% towards 50% without any significant plant change other than software combustion mapping. That's really, really encouraging in terms of getting us really swallowing capacity for hydrogen in the States. Particularly when you think about 40% across 5 machines. We've got an initial feasibility study for CCS. I'll show you a little bit of a mock-up of what that looks like. In our current understanding, that's 5 discrete modules of CCS. The other products I've talked about, production, shipping, etc. We have a challenge in terms of getting CO2, waste heat, hydrogen, etc. across most of the paper. On the offshore wind stuff, I know it's not the subject of today, but it is where we're going. The Celtic sees a massive opportunity. There's 4 gigawatt leasing round going out there this year with Crown Estate. We're targeting at least a gigawatt of that. That's going to be huge for South Wales. That's each one of those 20, 25 megawatt turbines sat on an 18,000 ton potential foundation, concrete / steel, to 200-meter tower on top of that. It dwarfs everything we've got at the power station. They're targeting producer one of those every week to week and a half, and over the next 15, 20 years. So that is enormous engineering. Drag in huge amount of jobs, skills, pipeline, investment in South Wales to deliver that. And our big ambition is to produce hydrogen, build milk and get it to Port Talbot. We have MOUs with Port Talbot, looking at repurposing their steel production into production of those foundations. So if you can close the loop on decarbonising steel, protect those jobs in that work, and produce wind turbines that keep this thing going, that's your nirvana. And that's kind of where we're aiming. And what the UK government is the group of Freeport, South Wales, and then you see more hurdles to jump. But between Milford Haven, Port, and Port Talbot, Bay, Newport Talbot Council, Pembroke County Council, we've got a real opportunity to invest in large-scale port infrastructure, and Freeport encompasses the power station phase 1 development. So everything I have on the suite gets through to the end of this decade, effectively. Helps the economics of those cases, it helps us advance infrastructure. So we've got a huge amount of momentum here. There's a lot of money required. I'll talk a little bit more about that later, but we've got a great opportunity. So, in terms of the power station, the green hydrogen projects, we've got a phase 1 project with 100 megawatts plus. That's direct supply to local industry, offsetting their fuel gas effectively, and some transport use for the council. 2025 target for that. 2026 is probably so a little bit later. We're on with application for a larger scale green hydrogen project, 250 megawatts, through the illicit connection, 20 million for that connection. These are the kind of hurdles we're having to overcome. It's continuing to high costs in the urban development stages just to secure the food supply. I can't stress out how much grid can be an obstacle or a bottleneck. One thing I haven't talked about is last one on the bottom here, Wales and West. So Wales and West utilities, big utility provider for South Wales and Southwest of England. One of their projects is looking at a pipeline between Pembroke and Swansea Bay. Hydrogen dedicated pipeline, large scale. It needs us to be able to deliver blue hydrogen at volume to really make it viable. It's a massive opportunity for us to really connect production of hydrogen blue green across to Southwest Steel, and the times all work. So I'll show you roughly what we've got planned for that in terms of practicality. So back to the core subject a little bit. What are we actually planning in terms of units? I've got 5 machines. They tend to operate in a peak mode, as I said, where they come on over the peaks. Overnight, we tend to have 1 or 2 running to help stabilize the South Coast. So our general feeling on this is that the sweet spot potentially is a blend of these technologies to both get the power station away at scale with carbon capture and enable the build out of hydrogen scale at the same time to try and drive CO2 disposal and distribution using power stations. So post-combustion CCS, potentially 1 stroke 2 units. We've got studies that show single unit trains on that. We need to understand what we can do in combination to reduce the capex. We've been quoted something around 3 billion convertible 5 units. I think that's across the billion to go in the first place. So that's expensive. effective. We firmly believe in talking last night that there has to be efficiencies in terms of scale. So much more to do there. But we need to commit fairly soon over the next couple of years what we can do in terms of post-combustion. And my own view, probably a couple of years, gives us some efficiency of scale. Now that can still keep 2 million tonnes a year of CO2. That's just from that. We're going big scale straight away. The remaining 3 units probably in the middle there on a blend. It's shell and stable load. We can really get into proper combustion of hydrogen, understand what it does to the plant, understand the dynamics. We want and we'll design that to be fully flexible, 0% to 40%, slightly higher, so that we can flex our demand. Our view on this is that the best use for that hydrogen is driving structure build, driving supporting South Wales, South West cluster. So our ambition is to use the power stations to stabilise the variable. So we can give customers confidence that they can ask for hydrogen, give Shell confidence they can reduce the scale in a stable way. We'll flex the power stations to soak up the variable. That's the general plan, probably 3 units. We've commissioned 100% hydrogen study as well for gas turbines. Haven't got the results of that yet. Personally, I'm not sure we'll get to 100% when we start to use power out. It'll be interesting to see where that goes. I think the limits will be in and around materials. What's the balance of plant risk to it? A couple of stats just in terms of what we've got. The post-combustion CCS, we're being told we lose about 10% efficiency on that, so 60% efficient. We're being quoted 10% loss on that in terms of the that's a big impact to us. Right, it's work. It'll be very, very expensive if we balance out. For the blue hydrogen plant and the 40% blend, we're being advised that you can put 40% by volume into that process. You would lose output, but you can compensate for that by adding more natural gas. So if you go to 80% natural gas, 40% hydrogen, so your overall throughput now 20% what it was, the power output's roughly start. The disadvantage of that is that we've not gained 40%, but CO2 reduction is more like 20%. So these are the costs we're going to have to grapple with in terms of is that the right combination for us. But from what we can see, we can inject with minimal technical changes, 40% hydrogen. We can compensate for load loss. Now that study at the moment doesn't look in detail at the impact on the heat recovery boiler. So the energy source into the heat recovery boiler and steam, we can turn steam back to steam turbine shaft. We're going to increase the volume throughput of that boiler. We don't yet understand what effect that has. Whether the design will be different to change the producer. So we don't understand that piece of that puzzle yet. That may impact whether we do that top up to the full load or whether we do the rest of it in terms of the actual vehicle shipping. At the moment, Shell are going to deliver them from the manufacturing plant that will do blue hydrogen production on south of the Haven on our farm, tunnel CO2 across north of the Haven, with faction jetty, shipping, storage. Providers and being approached by many already additional Shell, but there'd be backup ships if something goes down with their process and potentially multiple disposal points as well, rather than being tied by a pipe to a single disposal point and have problems. So we do see resilience in that, and certainly it's plenty. Quick visualization of what it looks like. This is only part of the land we own. We own just over 300 hectares. power station stuff, relatively small part. Down here you can see the old basement, the old oil station was on the site originally. It's all still there, and the original turbine petrol. New site here, yeah. 5 modules. We recycled effectively the cooling water system, 40 tons a second of seawater through the plant to cool steam from the old site, comes in down at the top, comes out here in Southport and Way, is where we take our shared heat supply across to energy. So this is an early mock-up of what 5E post-combustion CCS might look like. These are completely separate things, or very little common plant between the two. That doesn't feel optimal to us. We're certainly combine two of them into a single regain frame potentially as we go. What's here is the wall around here, you can just about see. There's a big bank behind the power station. When the original power station was built, it cleared a lot of land below it down here. We need to clear area behind the site. So there's potentially £200 million worth of excavation behind it, clear a flat area. Capture. Anything we can do to minimize that excavation by being more efficient about the way we deploy this is going to be done. So there's lots more. It's just our first mock-up of what it's like. Given that we're going to have to build 2 initially, probably, we've got to decide which 2 and how do you lay it out. You could lay 2 sideways here and not excavate anything. But then we've got ourselves into a corner, we wouldn't be able to do anything else. So we've got to decide how we play. All this over here is air cooling for the CCS. Currently, our seawater cooling is fully permitted, and it's extracting seawater from spectator. Real wildlife. Chances of extracting more water are slim to zero. So anything we can do to either recycle water cooling, optimize between processes around including LNG on the side, or go air cooling. These are our options. The idea of more water is not. Now up here, this is phase 1 green hydrogen, neatly sat between the water treatment plant for the existing plant to supply water here, and over there. So that one we're doing final environmental assessments for, plan commissions in progress. We haven't taken final investments even perspective. This is the 250 megawatt plant that was further up the hill here. That's the one we're just securing a grid connection for. Blue hydrogen down there, right next to the refinery. So refinery S type architecture. That is next to that's for the refinery. So that will blend in quite neatly there and sit on the same pipeline away to the refinery in terms of they can build further projects up this hill here. So there's plenty of space for them to expand as we go on. Wales and West connection in terms of their pipeline to Swansea Bay, we reserve that field there for them. An API there, like between our projects and their pipe work, then subject to approval up the hill and away through Pembroke Town, where they're planning a big town heating project, and on to Swansea Bay. Complicated project, 100 different landowners along that route. We'll need to look, see what we can do to combine, open that with maybe water and power and what else we can do. And you can just see over there on the side of the battery project, just the corner of it, sort of the field there, big battery project there. And this is just in terms of timescale. I said we struggled for a grid connection for green hydrogen. The green hydrogen is going to come a year later than we hoped. It's phase 1, phase 2 over here, not on this plan yet. ETS charging end of the decade for 1/2 units probably. Shell's blue hydrogen project construction again, end of the decade roughly. Wales and West are targeting getting that pipe operational by 2030. So these feel like they come together, and they do all need to happen. Heat integration with LNG, if we can achieve that, that's subject to ability to cross the haven. So great wave of activity for 2025, and then massive construction cruising in the decade to really then when we go large scale. So potentially between our CTS couple units, 2 million tons, Shell probably 1 million tons a year there, possibly. We're going to go large scale straight away. It's extracted from the Milky Way energy cluster video, which is a good video actually. We launched at 2 weeks ago. To show the layout of what's around us and just how central power station here has become to the network of opportunities around. So we are effectively where the power flows in, where the hydrogen is going to flow out from, CO2 will flow out from at the hub. And it's that kind of a role to kind of maximise and try and drive infrastructure build using power stations. Ultimately, we might end up having enabled this infrastructure. We're part of green hydrogen stuff. And power station might be all post-combustion PPS by the time we finish, but we will deliver into hydrogen infrastructure. Could have done it waited for LTC. That's our ambition. The ultimate pipeline will come around this way, here, and the Haven interconnect from there. Right across the way, the project through the start of ramp up our technical understanding how we achieve hot water to be able to provide the power. And interestingly, probably raw water as well for hydrogen. Something that's not talked about much. And anywhere I go, it's a sheer amount of water and things hydrogen. I got a little graph of it here. This is the purple line down the bottom here is 100 tons an hour of raw water to the power station. That's our current capability of the well water to deliver water to the power station. The current power station consumption that will be mine. There's a bit of spare. Phase 1, the 100 megawatt green hydrogen project will take all of the remaining capability of water, most water you get into 2 hours down in 5. You go phase 2, like 2028, you need all of that green there. The blue is the Shell starting to come online with their boat. So see, we're immediately exceeding the current capability of supply, even with these small scale 200 megawatts. By the time we get to 2040, from the end of here, we've got gigawatt scale green hydrogen on the back of the Celtic Sea expansion, exporting that through the pipeline. Blue hydrogen production, soaking up the security supply, flexible demand from power station and up to field, possibly potentially as well. We're at 10 times the current capability of supplying water to Pembroke. And Pembroke is already water constrained, despite the rain. They were the last county in the UK to come off the hosepipe dam on December last year. They get very heavy demand from summer from the tourism, and they don't really catch enough water. So because we've talked to our water active in there, they've got a pipeline project raising reservoirs, catching more, transferring. But water think was roughly what they've got available to them now. If you get it halfway up this graph, not just up here, but part of the way up here, if we invest in what they can see as options. So we've got a lot of water. The last one here, this is a switch drawing, and I know it was shown yesterday as well, but it just shows the importance of the Haven and Pembroke right in the centre of that in terms of what's happening now. Supporting the build of the High Line, South and West hydrogen named the Culvert, enabling hydrogen to do. And Promethean Union is the UK-wide hydrogen backbone. Will come to Wales eventually. We'll get priority to do that first, but we'll be ready for it. Ready to establish. We don't have any very good. Going to enable that export is what really unlocks critical. Our star delivery is high. Give them.
Thank you very much for your presentation, Sharon from Brunel University. I would like to ask about the final, do you have a picture of the final efficiency comparing natural gas power plants together with CCS and the blue hydrogen power plants? Also considering that the blue hydrogen is an energy intensive process. So,
as I said, the 40% blend, we're told that we can save about 17%. We're told we can boost that with natural gas to achieve full output as well. Overall cycle efficiency, I'm not sure yet. And that will depend on the overall impact of the recovery boiler, which we don't understand that yet. The point to note here probably is that we're aiming for a future where the power station doesn't run that much and needs to be very, very flexible. And in that kind of a world where you're ramping on, you're spending a couple of hours getting yourself on, you ramp up to full load, you hit the peak, you come back off again. The overall efficiency becomes less important to us overall. So what we start to prioritize flexibility and reliability over efficiency in that kind of a world. But for a CCS plant, you know, we're going to be aiming for a dispatchable power agreement that gives us confidence to invest, start in terms of recovery and capex, and we'd expect it to be encouraged to run. We still don't want it running. There's enough wind, so it could still be pushed off. But most of the time, you'd expect it to be prioritized, a high priority that it would run. So efficiency is much, much more important. So within the CCS, we've got decisions to make around what do we do around, for example, the fact that the process bleeds steam off to regenerate the engines. That's going to reduce the efficiency of the steam turbine element of the combined cycle package. So your options are you resize those turbines to be more efficient with lower steam flow. If I do that, if the carbon capture plant trips off for whatever reason, then immediately I've got too much steam for my steam turbine to swallow. So I'm going to be dumping steam to the condenser. So in terms of the overall mix of what's the sensible thing to do, in terms of balancing reliability, flexibility to put the carbon capture in and out, depending on what's going on around CO2, shipping, downstream storage, whatever, or a plant problem, and the overall efficiency for the bulk of the operation that we will see. So we've got lots of decisions to make. There's compromises both ways, I think. I see that there are advantages to going carbon capture, trying to keep the thing low, optimize the efficiency. I can see that. Last night we were talking about other options that allow you not to use steam, but maybe electric to regenerate. Maybe that, there are different ways I can do that. Maybe give us options to not compromise the original efficiency of the plant in unabated mode. For the blue hydrogen, it's all about flexibility, dynamic flexibility to flex the percentage and to flex the unit up and down rapidly. That's what I'm aiming at with those units. And I suspect we get to a point further down the line where we don't invest in carbon capture in all of these machines. There'll be so much floating wind in 20 years' time. You don't need 5 machines at Pembroke anymore. You're coming down to zero. You probably optimize post-combustion, 2, 3, 4 of them, and then you use the other inflexible mode on blue hydrogen, and the world moves on. That's kind of where I think we're going. A roundabout question to say I don't know, more or less, but we've got lots of choices to make to try and optimize how we want to use the machines.
Well,
Sorry.
thanks for presentation and the mind-boggling scale of it as well. So you were talking about the water that you needed, and it also came as a surprise, but it makes sense. Then when you split this water molecule, you're creating the hydrogen you need, but you also have a huge amount of oxygen. You haven't talked about that.
No, and it's a frustration because you ought to be able to use that. Nobody at the moment is interested in taking it away from us, which is a surprise. You'd have thought there's an opportunity there. And at the moment, I haven't got another process in this mix that's going to consume anything like what I need to to balance it. There are some synergies, I think, between green and blue in terms of transfer of oxygen across to blue in terms of that process. I don't understand the detail of it, but I believe that's correct, but nothing like the scale of what we're going to produce. So there's a big opportunity around oxygen. And I don't know the answer to that at the moment. Most of what we're doing ties up really quite neatly in terms of cross heat cooling, sharing of things. The cluster is really helping us here in terms of access to industries that help to soak up, the byproducts of all this and make this work. There's a lot of moving parts, but at the moment I haven't done an answer for Oxford. If anybody has one, I'd be delighted. Sorry? Well, yeah, I suppose, you go oxygen process and you don't need carbon capture. Yeah, get another pipe at the same time. I'll talk to Wales and West. I am. We're due to sit down with Tarka and have a proper technical discussion. We haven't.
There are an oxygen constraints.
Okay.
Let's thank Richard. So our final speaker is Frank Morton from the US Department of Energy National Carbon Capture Center. Frank currently serves as a consulting engineer for the US Department of Energy National Carbon Capture Center after more than 40 years experience as a chemical engineer in his industrial and research roles. He's responsible for bringing university, government, research and industrial organizations to the Center for Collaborative Technology Development. He's evaluated projects from more than 100 organizations involved in carbon capture research and development, and has established collaborative testing arrangements with more than 40 organizations. And he has a huge international profile, but I'm not going to read that.
Thank you very much for the opportunity to talk today. Us from the US are always glad to come back to our mother country to share in this difficult task we have together. I'm going to talk about the National Carbon Capture Center, give a quick overview. We have started an international test center network. University of Sheffield has been chair for the last 2 years. Our speaker from this session yesterday from University of Kentucky, Kun Lu, is the upcoming chair. So we've had a good exchange of knowledge internationally, thanks in big part to John Gibbons. So the NCC is a engineering scale test center established by the DOE to take test technologies that they've developed in a fundamental level for decades into an industrial setting. That's a huge risky step to take technologies out of the lab. The DOE had been taking technologies and trying to get a real world setting to prove them, but they were having to rebuild the infrastructure each time. And so not very cost effective. So in 2008, 2009, they came to us to establish an infrastructure, and we have put that in place, started testing in 2011, and have tested 70 technologies from 8 different countries since then. So off to a good start with 80% funding from the Department of Energy. The center is run by a Southern Company. I'm a Southern Company employee. It's a large utility in the southeast part of the U.S. We have taken on the burden of the 20% funding for the facility, and we share that with the partners listed on the right. One of the drivers for the interest in the U.S. is the net zero or the net negative carbon future that's a part of all the industries listed here. All our partners, including the Southern Company, have a strong program for a net negative future. So that's been a driver for our facility to get sponsors and get additional funding. The center started out as a point source for capture from coal plants. In 2008, 2009, when we first started getting funding from the U.S. government, that's all anybody was talking about. Of course, since then, U.S. is moving rapidly away from coal, like Britain has. And so we have added a natural gas boiler. We do point source from natural gas generation, and we're adding direct air capture, and we've added utilization to our scope of work. The location is in Wilsonville, Alabama, just south of Birmingham, at a power plant by Southern Company. We emphasize commercial designs on these small pilot plants, and with the center itself and our partners and the technology developers are fundamental researchers, and we rely heavily on universities and fundamental research from industry. But the goal of once you enter the NCCC, and the goal of a lot of the DOE funding going forward, is definitely putting cost-effective technologies on the ground. We're constantly reminding ourselves that it has to have a cost saving, it has to be a performance improvement to go forward. What our center has that others don't is mainly the huge amount of the DOE funding, and we have 100 people of a full staff that cover all aspects of a successful test and an extensive infrastructure. The goal of the NCCC and the goal of DOE is international collaboration. So I mentioned earlier that ITCN, the International Test Center Network, we're having a meeting in Sheffield tomorrow. We were severely affected by the pandemic, more than most people, but we're glad to be meeting face to face again. So that is the NCCC. There's a natural gas boiler on the left side of the pilot scale that provides steam and natural gas, flue gas to our carbon capture development. We're in front of this picture is a coal plant. So we have about 3.5 megawatts worth of coal flue gas going to this facility. This system here, the pilot PSTU, pilot solvent test unit, is about 0.5 megawatt solvent test facility. If developers gave us just a couple of thousand gallons of solvent, we could run that for them. That's the easiest way to test. The slipstream test unit right here is a smaller version of that, divided by 10 in size. So beyond those two tests, where a developer can deliver us a solvent, the rest of the testing that we can do is with a module. These are all about 1 megawatt size module. That's a concrete. That is a cryogenic test, and this is a hybrid contactor, a membrane contactor. So wide variety. So we've done 70 tests. The full DOE program plus some. You're not required to be a DOE program. But we've had tests from 7 different countries, and those didn't come with DOE funding at all. DOE is generous about looking at technologies that have a potential to improve the commercial readiness of CCUS and supports the incoming. Then we have a couple of smaller test facilities that we can very advanced slipstream type tests. So this is a quick summary of what we've done. About 130,000 hours of testing. We're often doing 8 tests at the same time. I've mentioned a few of those points. One thing that we're always doing is expanding the capability. When anybody comes, all 70 tests were unique, and I handle the upfront planning and the contracts. Every contract is different, and so we add capabilities to the test facility whenever we do a test. The model for the facility is that if you come and use what's already existing, the existing staff, the existing infrastructure, there's no charge for that. If you have something that we need to add just for you, then you would have to come with that funding. So very cost-effective way to do a test. And a big advantage is the flexibility for testing at multiple scales. We've had membrane come and test with us from MTR for 11,000 hours at different scales, from a tiny scale and scaled up to 1 megawatt, and now they've gone forward to larger scale elsewhere. With that, we try to stay involved as much as we can in helping the test be successful at a larger scale. We feel that is a big mission of our facility, is to scale these technologies up and get them ready for the marketplace. And on the bottom line is the amount of funding we have for the last 5 years is $140 million. Previous 5 years have been $200 million chunks for 5 years. So generous funding from DOE gives us a lot of capability to solve problems with the testing as they happen, and to complete tests. Once someone comes to us, and we've had a couple years of planning, and people have come sometimes from around the world and to our site to test, you know, we put all our resources into keeping that test going. So I won't talk too much about the ITCN. It's been a great avenue for us to build relationships, have facilities around the world that are listed on the map. We have 4 or 5 more that are asking to join. I think with the interest around the world growing, I think it will get bigger. We try to keep this as an informal user group type of mission to just help each other out. It's nice to have 200 friends around the world. There's a lot of people that are sympathetic around the world to the problems that we're having, and are willing to help out and share public information. All these facilities were built with public funding, so they all had requirements within their facility to share information. So once you get engineers together, they tell me about your problems. Everybody gets real open, and they tell you the truth. And so it's a lot of good conversations and a lot of helping each other. 5% of the time we might be competitors on a project, and we're convincing everybody that we're the best ones in the world to come to our facility, but most of the time we're just helping improve these technologies. I'm going to be brief on this. I get a lot of questions about the support of the U.S. on CCUS. It has come together to me magically over the last summer, which seemed impossible for all of us that have been dealing for decades with trying to get everyone's attention for CCUS and getting support. But there is a lot of support being pulled together, not just from the obvious things you see of the legislation for funding, but a number of bits and pieces of U.S. support for what we're doing has been real helpful. So there's a lot of new technologies being developed. There's second generation technologies, amine solvents, and others that are ready to deploy. You know, they need to be cheaper. They need to scale up. You need the learnings from scale up and commercialization to improve them, but they're ready to deploy. And then there's many transformational. A lot of what we heard today, or what we've heard in this conference, are transformational technologies that have a chance over time, and they need to be continued to be supported, and they are with this legislation. But we also have the urgency of needing to deploy technologies soon to start making a difference on reduction of CO2 now. For the CO2 that's being released into the atmosphere now. So what has happened? The policy incentives get a lot of attention. 45Q, the BIF. I'm going to use acronyms, and they're all on the presentation that will be available. Most of the incentives and the policy incentives for CCUS are from the federal government, but now the carbon, the low carbon fuel standard from California has been helpful. There's some states that are buying pore space. That in Wyoming has been very helpful with supporting a lot of the technology that we're talking about. So So it states in addition to federal support. Commercial risks are being reduced through regulatory and legal frameworks. Nobody wants to fill out a class 6 permit. Nobody wants to do all the bureaucracy of getting these permits. But you can't go forward without reducing the risk that these provide. So those of us that have been going through the process and complaining about it nonstop, realize that it's very helpful to have these in place and getting support, bipartisan support throughout the U.S. to get these done. The DOE, in addition to the incentives that are making the news and the large numbers of funding that's available, have always been supporting this for decades. The NCCC and our previous version, the PSDF that developed IGCC, has gotten steady funding for 30 years from different administrations. There's a lot of different rhetoric from any government, what the public policy is versus what the support underneath that rhetoric is, that we know that we need advanced energy systems, we need reduced carbon footprint going forward. So DOE and fossil energy and carbon management has done many FOAs, a lot of funding of individual projects. Most of the projects that come to the NCC were with DOE funding. There's a lot of federal agencies. When there was some sag of incentives from the government, there was a lot of agencies within the U.S. government, the EPA, the Department of Interior, that were supporting this directly without legislation. So that's provided some benefits to move forward. And of course, then there's the workforce development and supply chain development that's not mentioned enough. I know that you've heard it and we need to do it, but it's something that needs to start now because of the magnitude that was just described of the project in Pembroke. Think of the workforce and supply chain that is needed to support them. So I won't go through the details of this, but if you look at line 2, the different support from the U.S. government started in 2008, went to 2018, and then last year at the IRA, we went from $20 a ton for carbon support, which was a drop in the bucket, and nobody responded. Wasn't enough money to move forward. A 45Q got to 50, so that brought in more people. It was starting to see that some of those would work. Coal projects could work. Natural gas probably couldn't. But now with $85 a ton, and with direct payback is another option, that's something that can work. And so things are starting to happen. But this happened. It didn't happen last year. It happened over 15 years of gradual government responding to industry comments to make it work and then coming together. So we need to take advantage of that. Times are good. That we need to look forward to the opportunities that we have now in the next 10 years to get all this hard work that we've done on the ground. And those are some of the dollars. I know that y'all have been polite and listened to me talk about how smart and successful we've been, but everyone's interested in dollars, and so I know that's what we're interested in, and so that's a lot of dollars. This is just one bill, $12.1 billion. We thought that was impossible. That was unbelievable. They announced it during a large DOE meeting. There was 1,000 of us together in Pittsburgh the day they announced it. I don't know if there was any timing associated with that, but there's lots of happy people that the decades of work we've done, there's money available to build large scale projects now. So just the first one is the CCUS demonstration project at $2.5 billion is something that affects us directly. And as a result of that funding, Xi Liang yesterday talked about the increase of projects in China over the last couple of years, and they've shot up the roof. This is a GCCSI numbers. Look at the increase in projects last year, and I'm predicting a similar increase next year. We're past break time, so I'll stop it there. I know I didn't go into a lot of details, but I'm around. I'm easy to find. John Gibbons always knows where I am. So I do want to talk to everyone. There's my email address. Please use it, and I would like to hear what your comments are. I'm not an expert on any of the incentives from the U.S. in general. I am very active in forming partnerships and putting teams together to scale up, and I'd be glad to talk to you about projects that you're considering in the U.S. I get calls every week, several times a week now. We're interested in the U.S. market now with all the support, and let's start talking about forming partnerships. We want to help with that if we can. So appreciate it.
Okay. Got time for a quick question? Yeah, go ahead. Hi.
Thank you. Hi, Alina from Cranfield University. Actually, we have a lot of pilot facility at Cranfield, and we used to be a part of PACT. We have kind of pilot from kilowatt scale to 1.5 megawatt scale, and it's based on solid looping. We were looking actually to be a part of kind of national center or global center like this, and I think it's a general question for everyone here. So which sort of carbon capture technology are you looking for, and what is the route to join you, and potentially which sort of a scale you are looking for? Thank you very much.
So as far as the National Carbon Capture Center goes, we're totally DOE funded. And so there's a process of just a technology screening document. We do an NDA and then a contract of how we might work together and how we would separate the tasks. So very simple. It's not like a DOE proposal that's a huge proposal and you get a yes or no. We just kind of work through whether or not we're a good fit. So it's mainly talking to me and seeing what we have and what our schedule is and if our size fits. And then often with our International Test Center network, I might suggest another facility. So mostly informal, just a general conversation of how we might work together. I'd be glad to start that conversation.